That doesn't make any sense. Why are you?
Maybe he just stopped by to say hello.
Yeah.
But the thing I love is that ASP.NET under our client isn't in there, but Jeremiah Grossman is. Yeah.
Yeah, it's like, really? Does nobody look at this stuff? So that led us to say, well, we need to generate our own word lists. You know, how do you approach this problem? And we said, well, let's think about some way that we could go out and find words that people are telling us not to look for. And if you're familiar with the robots.txt exclusion standard, basically webmasters go through and they mark parts of the site that they don't want Google spidering. You know, maybe there's sensitive data there, or maybe it's underlying web application components. So those are the kind of things that when we're doing an assessment we're very interested in. So we went through and we pulled down the robots.txt file from a lot of sites. We combined the Alexa and QuantTask top million sites and pulled down about 1.7 million. We made about 1.7 million requests and found 350,000 unique files. And we went through and we generated word lists based on how prevalent certain words were. So it's kind of like we crowdsourced what people are telling us not to look for. So we've been using those on our assessments, and we're seeing that we're getting better results back than when depending on the Dirbuster list. So those are out in our SVN on Google Code. You can pull them down. Right now they're just in a 7-zip file, so pull them down, look at them. You know, if you think they suck, there's probably some stuff in there that doesn't make any sense. You know, let us know, give us feedback.
So one of the things that I always like to say is that tools don't find vulnerabilities like people do. So tools should be there to assist in identification of vulnerabilities, not exactly point them out. So if you have a tool that's telling you something is vulnerable, the tester has to have the knowledge to look at that data and say, yep, that's an actual vulnerability, or it's not a vulnerability. So we decided that there's too many tools out there with absolutely no intelligence when it comes to the sort of fuzzing or fault injection testing of applications. So if you had like say you were testing for SQL injection and you have a good SQL injection list that you want to test with different values, with modern applications a lot of times those fall down. So if you've right-clicked on your favorite tool and said send to insert semi-automated testing tool here, if there's a CSRF token that changes every single time the page is laid out, that means every single one of your tests is going to fail. It's going to come back and say, you know, yep, not vulnerable, or depending on the error message that may come back, you might be able to identify that. But that's a big problem. So, because often you can use, you know, automated tool, and it might not find an instance of SQL injection that was very easy to find if the person would have tried to test manually. But they're using these semi-automated testing tools, and it's failing, and they're assuming that they can move on to other tests. So a smart tool, a smart semi-automated testing tool should have several components. It should have session management, obviously, because we want to make sure that our tool is smart enough to stay in session. It should have sequence building and running. So if you have a difficult test case, you might need to run a sequence of events prior to sending your test case, and even a sequence of events after you've ran the test case. So for instance, you may need to run a sequence of events to log you in, run a test case, and then log out. There are crazy weird applications like that. A lot of international money transfer applications have weird functionality like that to try to make them more difficult, I guess. So security through obscurity. But any tool that can handle those three things can test them rather easily. Also content discovery and support for like modern technologies. So we all know that something new comes out, developers want to use it. It always takes testing tools time to catch up. So here's our tool. We're going to start talking about how we solve these problems and how you can use our tool to help you solve some of the same problems. So a little bit of history about RAFT. It was written, it stands for Response Analysis and Further Testing, which is actually on the next slide. I probably shouldn't have said that. But you're probably wondering why there's a big red raft in the center of the screen right now. So this tool was created because I was on an engagement and I had to write some custom scripts to test some functionality of a web application. And I got to thinking, there's this data I'm collecting and I'm looking for something specific. Quite simply, I wanted to be able to see the data, syntax highlighted. I wanted to be able to see the data rendered in some sort of web view, and I wanted to be able to parse out scripts and comments and all the general things. So I created a simple Qt interface that allowed me to do that. Of course, the tool today looks absolutely nothing like the beginnings of it. So
yeah, it used to be just basically a SQLite browser.
Yep, with focus towards web technology. So basically, it's not an inspection proxy. So that might throw you for a loop a little bit. But we decided to take a different route and kind of change that paradigm that everybody's used to. Because if you think about it, you're just chaining responses through another device or another application.
So that's really important because almost all of the workflow that you see on all the other tools is, well, you'll set up this inspection proxy, use whatever browser you want to go browse through the site, and then come back and look at the tool again. We decided to just cut out that middleman, and instead you can import data if you already have it, or you can just use the browser that we have ourselves. So we actually built WebKit right into the thing, so it works just like your Safari or your Chrome does, and it renders things the same way. So a lot of tools that have their own browsers, they often have something that's kind of not as full-featured or is just a little weird. This one is going to work just like you expect it to. We also, a big piece of this is we made a custom analyzer engine, so you can write whatever it is you want to find easily and then run it against all the stuff you have. It's all open source, it's Python and Qt, and it's designed for testers. This is not a fire and forget, click the button and your report is done tool. This is designed for someone who already knows how to test web apps, but they just need something to help out. So now we're going to have the demo. What you've all been waiting for.
Yeah, we got through like the boring technical stuff, so we'll see if we can get this going. All right, this is the user interface, and we're sorry about the screen resolution.
Yeah, screen resolution looks like crap.
Yeah, this has a little bit different workflow, like Nathan talked about. This started out as a way to look at data from other data sources. We have our own capture format that we have defined. It's an XML-based format, and what we have provided a DTD for you, and there's a urllib2 module for people to do Python that you can just plug it in as a processor, and it automatically generates this format. So we'll look at some data we've captured, and I just want to point out here, we're off the internet anyway, but there's an important thing that we discovered is when you're looking at rendered data from old assessments, you may have a limited time window for your testing, and you're not supposed to be interacting with the site. So we have this black hole network, so if you're looking at old response data, there's no traffic being sent out to the internet. But when you have captured data, if you have all the references, all the images, anything that was originally referenced, then the built-in rendering will pull that out of your capture data and display the web pages that originally existed. We have responses. Here, I'll zoom this in so you guys can see. We have the zoom feature, which is really handy. You can see the request, the response. I don't know if there's any scripts on this, but we pull them out. I'll find some with comments. Links, we pull out all the links. So you get a quick view of what all the references are. Any form values, you get those. And we kind of go through and parse out of the DOM and generate the list of forms. And then one of the really handy features, if you do a lot of assessments, especially with highly dynamic applications, you know that you have to do view source a lot, view generated source. So we have the generated source that we render the page and pull out of the DOM. And any of these references like links and forms that are dynamically added, those also get included here. So that's pretty handy. So that's imported data. We also support from the RAF format. We also support burp logs, burp state files. If you use Burp Pro, you know the saved state files. That's and the XML, saved XML, and WebScarab and Paris message log formats. We don't do their storage, but we're working on that because it's not a good interface. We also have our own built-in web browser, so you can go and pull up sites. So let me copy one here. I can just type that in.
Yeah, don't get into my porn.
Yeah, definitely. So we just have an instance of the broken web applications running locally here.
So this is a simplistic, I don't know why I'm bending over like that, that just looks strange. This is a simplistic view of our browser. It's made as a proof of concept, so in the future we're going to have...
Yeah, the question we got the most is there is a back button, you just have to right click in the page to go back.
That's terribly intuitive, we understand.
Yeah, we definitely have some UI, you know, we're not GUI designers, so we have some like UI inconsistencies, so you just have to work through those. But as... close that, and if you if I scroll down here, we'll see that any requests that we've been making, yeah, we have a zoomed in view. So those requests that we were just making are now being saved in our storage. We use SQLite in the back end, so those are just getting saved to a local storage database. Other interesting tools. We have a little search engine. You know, you can go through and type in, like, let's say you want to look for HTML comments. So this one will have some comments in there. And we offer, a variety of search routines. There's a built-in differ. Let's see if I can find some pages that are similar. Oh, I'll just pick two that aren't. Just so you can see the differences. Yeah, this is like a really bad example, but it's syntax highlighted. It's using the built-in diff live in Python, if you're familiar with that. So it's based on word matching and not byte positions. We're going to cover some of these things like the analyzer, the requester, like simple tasks, like requesting a whole bunch of URLs that other, like going through and saying, well, copy my sitemap and re-request them with a different authentication sequence. That's like really tough to do in a lot of tools, but here we have it all templated out, and you just copy the URLs in here, pick a sequence, and rerun it. Our crawler is a little bit different. It has the traditional web spidering approach, but in addition to just pulling down and analyzing the raw HTML, it also renders anything, so highly dynamic web applications that, that are based on Ajax or some other rich client technology. We can go ahead and pull out any dynamically generated links and follow those. We generate mouse events, text events, submit forms, do clicking, all on dynamically generated basis. We have an encoder. Probably the most interesting thing was UTF-7, generating malformed UTF-7. There's a lot of WAFs out there that check for UTF-7 in cross-site scripting attacks, but they don't check for malformed versions, and web browsers are more than happy to render UTF-7 if it's malformed. We have a data bank. It's going to hook into both the spidering and any sort of sequence if you do replacement, dynamic data replacement. We'll cover that a little later. Sitemap. You get a view of the sites. Cookies. In addition to your traditional cookies, we also have offer views of flash cookies. So this is pretty uninteresting. Nathan cleaned all the porn off his machine, so all those flash cookies got deleted. Right now you can only view them, but we're going to give you the ability to edit them. That's really important, like if you're testing risk-based applications with risk-based logins that are storing data in those flash cookies. Getting a good way to go in there and edit those values. And HTML5 local storage. I'll go through a little bit of a demo of that later. And that's about it for now. We're going to start covering some of the other interfaces.
J-Rock doesn't know how to use a Mac, so
sorry, guys.
We have to drive it for him.
So, yeah, as the regular consultant, I get all the boring slides too. So, we run on Mac, we run on Linux, we run on Windows. Mac works pretty well. Windows, you've got to do some compiling. I'm not going to go into the boring details. The easiest way to use this right now, if you have Backtrack 5, you have to do one apt-get install.